Hi friends, this is in continuation to our previous video where we are saving to build deep learning model for XOR design. So I was supposed to illustrate the building of this model with Python and R language. So first let's start with Python. Assuming you have installed Anaconda Navigator, go to Anaconda Navigator and launch the notebook. So once you launch the notebook, you will get an interface like this. So first thing is we import the library. So we import this Keras library. Now as mentioned earlier, Keras is a high-level API that uses either TensorFlow or Theano at the backend. I also import NumPy and Pandas libraries. So there are two ways you can go on building the Keras model, that is either sequentially or functionally. So if you create a sequential model, it is nothing but creating layer by layer, and if you say functional, it means that you can connect any layers to any other layer without just following the sequence of next and previous layer. Then I import this sequential and also import activation and dense function from the Keras library. So we use this then function to create a fully connected layers and number of neurons in each layer, while the activation function is specified in each layer. So Keras supports a number of activation functions including ReLU, sigmoid, softmax, stan, elu, etc. So more details of this can be found at Keras documentation. The first thing that we need to do is first we prepare the XOR data. So we set up predictors and target data according to the functioning of XOR gate. So as discussed earlier, XOR gate, if the inputs are same, then the output is 0, else the output is 1. So first I give the input data, and according to that input data I define the output or the target data. Then the next thing is we construct the model. So first we initialize the model. So here in this case we initialize a sequential model. Then we create the model and add layers. So we use the dense function to define fully connected layers and number of neurons in each layer. So in our example we use 16 neurons for the input layer and the output layer consists of 1 neuron in case of a regression of binary classification problem, whereas the output consists of n neurons in case of a multi-class problem where n is the number of classes. Okay, then we specify the activation function in each layer. Right? So that is what it is specified: activation ReLU, activation sigmoid. Then After we create the model and add layers with add function, we need to compile the model. So when we compile the model, we have to specify the objective function. So for regression problem, the available function include mean squared error. For binary classification problem, the function is binary cross entropy, whereas for multi-class problem, the function is categorical cross entropy. And there are many more other functions also. The second argument is the optimizer for estimating and updating the model parameters. So here there are several optimizers for ranging from SGD, Adam, Ada Delta, etc. So in this case we use Adam, and the metric used is accuracy to assess the performance of the model. Right? So we use the compile function, and then the next step is to fit the model. This is a crucial step. Here we input the data on which you are fitting the model with the predictors and the response with fit function, and we use the number of iterations. So NB epoch here indicates the number of iteration, and verbose shows the training progress. So if you mention verbose equal to 0, then there will be nothing showed. If you mention verbose equal to 1, then an animated progress bar will be shown. And if you mention verbose equal to 2, then the training will be shown as number of epochs. Okay. Then we create an unseen new data or dummy data to validate our model, to examine the functioning of the designed XOR model. And then after you create this unseen data, we do the prediction on the unseen data. You can also check for different number of epochs and different configuration of verbose. Okay, so let us run this code step by step. So first thing, I import the library. Yeah, so you see using TensorFlow as backend. Next step, import the sequential and active functions. Then prepare the data for XOR. Then initialize the model. Then create the model and add layers. So you see we have 16 neurons for the input layer and 1 neuron with activation function as ReLU and sigmoid. Next we compile the model and then fit our model on the respective data. So now, since we have mentioned verbose equal to 2, it will show the training progress in terms of epoch. Yeah, so initially our model begins as a dumb, but then over the iterations, you see that accuracy of 100% is achieved, and the loss of information is also eventually decreasing over the number of epochs. Now then we create the unseen dummy data and then do the prediction on the unseen data. So as per XOR truth table, similar input should give 0. Similar input should give 0. Okay. We also check for different number of epochs. So this is a simple demonstration of deep learning that is fitted for XOR case study. Okay. Now the good thing about Keras is that its implementation for Python and R are almost similar. So we will see for R. So just open RStudio. Okay, so I have opened an RStudio. Yeah. So first I clear the workspace and memory, then set the working directory, load the library, then prepare the XOR data, then define the sequential model, then create the model and add layers. So if you see for input layer 16 neurons as we saw in Python, and for output layer 1 since it's a binary classification, and the activation function is ReLU and sigmoid respectively. Next, after we create the model and add layers, then we compile the model. Again, for compile you have this compile function where the loss function is binary cross entropy, the optimizer used is Adam, and metrics is accuracy. Then we get the summary of the model. So this gives you the layers and the neurons information. Then we fit the model on the training data with number of epochs here given as 500 and batch size mentioned is 10. So that much of data is passed at each epoch. So the training is completed. Now you see by the end of the epoch the accuracy is 100% and loss is also eventually decreasing. Now prepare a dummy test data and then predict on that unseen test data. So we prepare a confusion metric. So it shows that for same input and then we measure the accuracy.